However, if we look at this case in which the amplifier is the same, but I have flipped the input, and the amplification, as far as the amplifier is concerned, nothing has changed internally, which is it amplifies from plus to minus, and so V output is still, let's say, V plus and V minus. So V output, is still equal to amplification into V plus minus V minus. But in this case, the one thing you can see very easily is that if you have a large output, let's say it's stuck at plus 10 volts. If this is 10 volts, then the 10 volts sort of can feed itself. This is a positive sign, this is at ground, so the 10 volt, as a part of it, feeds itself and can keep feeding itself. So this is called a regenerative positive feedback. It generates itself again and again, and this makes it get stuck at that 10 volts that it started with. So in most of the circuits, what we will be using is negative feedback, and negative feedback helps to control gain. So you have an expected, so control is also expected. You can expect what the gain is. And it doesn't really depend on the exact amplifier you're using, as long as the amplification is large. But in a positive feedback circuit, you very rarely use positive feedback circuits other than as limiters. So limiter means if you have a signal and you pass it through a limiter, the output you will get will basically be limited to the supplies. And the one place it is used is to introduce hysteresis, which is memory, and we'll look at why hysteresis is important in a second.